log. So what's a log? So if I write, say, y equal to a to the power x, this is called the index form. We can write that in log form, right? And the log form is, you make the x the subject, and you write log base a y. Okay, that's what we did last lesson. So for example, now we can calculate things like log base to 8. What's the answer? That will be 3, because 2 to the power of 3 equal to 8. Okay. We also learned about some properties of log. Log of 1 is 0. Log of a is 1. And we also learned that log of x, the domain and range, the domain will be x positive. The range will be all real y. All real y. Okay, that's what we did. We also did the graph of a log. Looks like this. That's a log, has a vertical asymptote, across the x-axis at 1. And yeah, that's what we did last lesson. Okay, so we're going to continue on today with log laws. So go to page 4. Page 4. Okay, so now we're going to look at log, which is this. Okay. This. Okay, so we continue. Alright, let's look at the first question. As you can see, they're all the same. It's like collecting like terms. So if I add y plus y is 3y. So we can write 3 log base 2x. Yep, that's the first one. So we can collect like terms. Alright, how about the next one? The next one is, you just go 3 plus 4, which is 7, minus 3 is 5. So write 5 log base 2x, like that. And how about the other ones? Now the other ones, if you have different bases, you can't add them. So these two are like terms. So 1 minus 3 is negative 1, negative log base 3x, like that. And then you go plus 2 log base 5x. That. So these are not like terms because they have different bases. Okay. All right. How about the next one? They all have the same base, but if they have different pronumeral, they are not like terms. So these two are like terms. So 5 minus 2 is 3 log base 4x. And then these two are like terms. So 2 plus 3 is 5 log base 4y. Okay? Okay. All right. Okay, let's continue. Thank you. All right. All right, now we're going to go through some log laws. These are very, very important. Very important. All right, very important. Let's continue. So again, to learn these log laws, we're going to do some experiment. So let's look at the first one, log base 10. Let's do what's inside the bracket first. So log base 10, 1,000 times 100 is 100,000, isn't it? So write 100,000. Now, what's the purpose of all this? Now, what would that be equal to? So you ask yourself, 10 to the power, what become 100,000? What's the power? 5, yeah. Because 10 to the power 5 is 10,000, 100,000. All right, good. So also calculate the other one on the right side. So 5. And then you can also do the other one where they add them together. Okay, so do the first one, log base 10, 1,000 years. This is 3, right? Because 10 to the power 3 is 1,000. The next one is log base 10, 10 years, 100 years, 2. So what's 3 plus 2? 5. So they have the same answer. So what we conclude is that when we times these two things together, it's same as adding the two log together, isn't it? So they are the same. So it's like doing index law. So if I go 10 to the power of 3 times by 10 to the power of 2 is same as adding the 3 and the 2, isn't it? Like we did before. The 3 plus 2, which is here, is same as 5. So you can think of log is an index. The index of 10 to the power of 3 and 10 times 10 squared is same as index of 10 to the power of 3 plus index of 10 to the power of 2, right? So, and then we arrive on this log law, which is written here. That's the first log law. When you add two logs together, it's same as log of a product. Or when you do log of a product, you can change it to plus. Okay, so you have to memorize. So of course, memorize. And I have a highlighter. So if you have a highlighter, highlight this. Not on the formula sheet, okay? So you have to memorize. Okay, now we're going to do more log law, but before we do that, let's apply this log law to example 4. How does that work? Using the example log law 1, you can get log base 6. When you plus, what do? We times them together, 12 times 3, right? What's 12 times 3 is 36. Now, what's log base 636? 2, yeah. So I can't calculate these two, but when you combine them, it can actually becomes an easy number to calculate. Okay, good. We're going to do more experiment. So we'll try with the next one with division. So let's do the next. So calculate what this is, calculate what this is. What's this one? Log base 10. 1,000 divided by 100 is 10. And log base 10 is 1. How about when you subtract? This is 3, right? Subtract 2. 3 minus 2 is also 1. So division has the effect of divide. So when we divide numbers, we subtract the indices, isn't it? And this is what this rule is about. We're going to go to the next page to complete. All right, so basically log law comes from the index law. So let's go to the next page. So we conclude that this is same as log base 10. So when we divide, we subtract the two log together. Okay, subtract, yep. Yep. Minus that. Yep. Because this is, so basically you can think of index of 1,000 is same as index of 1,000 divided by 100. Index of that is same as index of 1,000 minus index of 100. Right? So it's like this rule. So if you divide 10 cubed divided by 10 squared is same as 10 cubed minus 3 minus 2. That's where the minus comes from. Which we have this another log laws. So we're going to highlight this. Okay, so when we subtract, we divide the log. Okay. All right, done. Yep. Okay, now, what does that word say? Index of 1,000 minus index of 100. Yeah. Okay. All right, let's apply this rule. So when we subtract the two log, what do? We divide the indices. Divide. Yep. And if we divide, what do we get? 21 divided by 3 is 7. And what's that equal to? 1. Okay, that's the second log law. We're going to do the third one, which also relate to the index law. Let's go through this. Okay. All right, let's look at the next one. Okay, so we know when we times, we're same as adding them, right? We just learned that from log law 1. We can add them like that. And when we add them, we learned that from the beginning, they are all like terms. So it becomes 3 lots of log base 10(7), right? 3 times. Okay, so what do we do next? Another way to do that is 7 times 7 times 7 is 7 cubed. Right? 7 cubed. So basically they're the same thing. Right? They're the same. So what can we conclude? We conclude that if we have log base 10 7 cubed, it's same as 3 log base 10 7, right? So what happened to the 3? The 3 actually moved down, right? That's where the 3 go. So that's a very important law, which is summarized in log law 3. Okay? So let's highlight this. So like this, or you can write it in reverse. All right, any question? Yeah. All right, after this, we're going to apply to example 6. And this law is very important. It has applications to exponential equation as well as differentiation, which we'll look at later in the course. All right, so we're going to write the following: logarithm with no powers. So let's apply to the first one. So every time you see a power, you can bring it down. A little bit like differentiation, except that you don't write the power again. It just brings it to the front. Okay? Now be very careful. If there's a 5 in front of it, you can't bring it down. You have to split it first. So you write ln 5 plus ln. So you use the log law 1, split the 2. So ln x power 4, like that. So split into 2. And then that 4 can go down. So you can't pull it down if there's a number in front. So you do ln 5 for ln x. Right, done. How about the next one? Now, next one, notice that there's a bracket. If there's a bracket, you can pull it down. See the difference between B and C? I can't take the 4 down, but I can take the 5 down because there's a bracket. So that means I could write 5 ln 2x plus 7. Okay, good. Plus 7. Right, good. And then we'll do one more question. What if it's a square root? We have to write it in index form. What would that be in index form? Half. So you bring the half down. So you get half ln 5x minus 9. Okay? And bring things down. Bring it down. All right, any question? We'll go one more log law to do, then we'll do some more examples. Okay. All right, log law 4. Log law 4 is very easy to learn because let's see why it works. So if you have a reciprocal, it becomes a minus. Why is this the case? Because 1 over x is x to the power of -1. And that -1 can go down, right? So it becomes negative log ax. And the same thing when you switch things around, p over q become q over p, just add an extra minus. Yeah. So this is just application from log law 4, log law 3. So that just comes from log law 3. Okay. I see. From log law 3. Okay, good. Once you're done, please go to the next page. We'll do 3 more pages, then we're done. Example 7. Right, 7. So we're going to apply these 3 log laws. Let's look at the first one. Use log law to express the following as a single logarithm. Sometimes the question says, in the text will say simplify. That's what that means. So you have 3 terms. We're going to combine them. How do we combine them? First of all, we're going to use log law 3 to get rid of the numbers. These numbers have to go to the top first. That's your first step. Log base 3x power 4. So sometimes you have to use the law in reverse. In this case, we have to do it in reverse. Bring it upright and bring it down. Log base 3z. Okay. And then what we do is we're going to combine them. So the plus, what does the plus do? We can times, right? So it becomes log base 3 x power 4 multiplied by y squared. Yes? Using log law 1. And then when you minus, what do? We have to divide, or write it as a fraction, x power 4 y squared over z. It's your final answer. So I've combined all three terms into one term. Okay, so I apply all three laws in this question. First, get rid of the numbers, bring it to the top as a power, and when you plus become times, minus is divide. Okay, all right, try the next one. Next one's pretty easy. Have a try. And then doing this, easy, good. And then we've got equations, then we're done. Okay, good. All right, okay, all right, good. Part B. All right, let's look at part B. Part B is you do log base 5, you times them together. So you go x plus 2, x minus 2. What's a fast way of doing the expansion? Difference of 2 squared. Very good. So it become x squared minus 4 is your final answer. Okay? Okay, done. Okay, next question will be a little bit different. So we're now simplifying. This is how we simplify logarithms. We now have to find the values of these logarithms. How do we find the values? Let's try to get the values. So we have to apply the laws in reverse this time. We're given log 2 and log 5. How do I get log 10? Let's write 10 in terms of 2 and 5. So 10 in terms of 2 and 5 is 2 times 5, isn't it? And why do we do this? Because when it's times, it becomes plus. Log base 2a plus log base a5. So the times become a plus. And why do we do that? Once they are separated, I could now substitute by the values. 0.29 is the first one, 0.67 is the second one. All right, so that's how we do these questions. Okay, and then add them together using a calculator. You will get 0.96 is your answer. Okay, can you try the next one? See if you can work out. Write it as a fraction. Write it as a fraction. Okay, so 2.5 is 5 over 2. Write it as an improper fraction. Right, 5 over 2. Then when it's a division, it becomes a minus. Minus. And log 5 is 0.67 minus 0.29. Again, using our calculator, that will be 0.38. Like that. I'll try the last one, see if you can work out. So I'll show you all the tricks. Try the last one. If there's more than one way of doing that, I'm going to show you one way. So let's write 40. Now 40 is 8 times 5, isn't it? And 8, let's split it into 2. 8 plus log base a5. But 8 can be expressed in terms of 2, which is 2 cubed, isn't it? And then you can bring that 3 down. So you write 3 log base a2 plus log base a5. And your final answer will be 3 times 0.29 plus 0.67. And then using your calculator, 3 times 0.29 plus 0.67, which is equal to 1.54. Right, everyone got the same? Yep, all got the same? Yep, good. Okay, all right, let's move on to example 9. Example 9. Okay, again, we're going to use use log to simplify. So how do we do this? Okay, let's look at the first one, log base E, but this one using log law, that has to be 1, isn't it? Right? Now you can actually check this on a calculator. Just do ln. alpha e, right? It should give you 1, right? Gives you 1. All right, good. How about the next one? Log base e squared. So what do? You can bring the 2 down first. And then once you bring the 2 down, this becomes 1, isn't it? Which is 2. See if you can work out the next 2, okay? Try the next 2, and then we'll move on. All right, try the next one. Okay, next one. Well, next one just e times 1, isn't it? Just e, right? It's just 1. And the last one is 1 over e is e to the power of -1. And that -1 can go to the front. -1 log base e. And what's log base e? Which is 1. So -1 is your final answer. Okay, next page. 2 more pages to go. All right, so log law is really convenient. It's quite logical. Okay, let's use them to simplify more questions. All right, so it's like the question before. We have to write it in terms of P and Q. So we have to split them first. So split that into individual parts, like this. So split first. So whenever you have to find values, split. And once you split, any powers have to be taken down. That has to be taken down. So the answer will be log base a plus log base ax plus 3 log base ay. And then write it down. Write it down. So aa is 1 plus log ax is p plus 3 times q. Okay. Alright, I've shown you everything. Try B. Okay. I'll stop the video. Try B. Okay. Alright. So we first split into 2 parts. A squared minus log a x cubed square root of y. And then you have to split into more parts. Bring that 2 down. So you get 2 log base a minus in bracket. Very important. There's a bracket. X cubed plus log root y a, and then write that root y as square root of y to the power of half. So you write 2 log base a minus log base a x cubed plus log base a y to the power half. Okay, and that 3.5 goes down. So you get this again, 2 log a minus log a 3x plus half log ay. And then you can start substituting. Log a is 1 minus 3p plus half q. So the answer is 2 minus 3p minus half q is your final answer. Okay, good. Note the steps. You get it? Okay, which part? Do you understand? 1, 2, 3, this one, yep. Yep, because log ax is p. Yeah, we substitute. Yeah, like the one we did before. Aaron? X to the power minus 3. I split it. Yeah, you can do it this way. That's good. Log base a, x squared, x to the power -3, y to the power -half. But you're still going to get -3 in the front anyway. Yeah, but you get the same answer at the end. You didn't get the same answer, you got the +3. Well, because if you split that, if you split this, you get 2 log a, but then you get plus log ax -3. That -3 bring it to the front, become -3. So 1 be plus. Yeah. Yeah, all right, okay. Does that make sense, or can you see why that worked? Actually, we'll do another one. Let's say I make up another one. Let's say it was this question, log base A over B, right? So you get log base A, B to the power -1, which is log base A plus log base A, B to the power -1, and it becomes 1 minus B log base AB. That minus goes down. Yeah? Okay. All right, let's move on to some log equations. That's the last section we will do. Then we'll continue, and then you can do the exercise. Okay, let's do the next section, log equations. Now, log equations is actually quite easy. How do you solve log equations? Just turn it into index form. We all know how to turn it into index form. Let's go through the index form. So if you write in index form, you write 5 to the power x equals to 6 to the 5. That looks more familiar, isn't it? And then you're going to ask 6 to 5 to the power what is this? So you can do trial and error. You go 5 square, doesn't give you 625. So you go 5 to the power 3, that also doesn't give you. And then you go 5 to the power of 4, it gives you, right? So that's 5 to the power of 4. And when you do that, you just have to make the two index equal to each other. So x equal to 4. Get the idea? Now let me show you another trick with this. If you don't want to do trial and error, you can do this. Press 625 equal, and then press shift. See that fact means factorize? Gives you that. Yeah? Alright, let's do that again. So 625 shift. That one, I only learned that this year. After teaching for more than 10 years, that's the first. Yeah, okay, you press equal first, press shift. You have to buy the latest version. It has to have +2 at the end. Do you have +2? Yeah, if you have +2, you have it. If it's not +2, you don't have it, unfortunately. You must then buy from Office Work. Okay, get the latest version. Yeah.
This one.
Fact one. You have to get +2. +2. Okay? Alright. Alright. Yeah, get the +2. +2, okay? Alright, okay, let's move on. Okay, next question. Again, write it in index form. Alright, good, still recording. Okay, x to the power of 3.5 equal to 128. And then this one's a bit different. It's different from how we solved the first one because we're finding the power. This one we're finding the base. So when you find the base, you have to root it. Just do root. And you can do that on a calculator. Do 3.5 root. So you go 1 shift. This button here, write 3.5. 128. It should give you maybe 2 or 4. Okay, so the answer is 4. Okay, got it? Okay, done. And then we'll have some harder one. No, harder ones. Let's look at the next one. Okay, next one is if you have got more than 2 terms, combine them. How do we combine? We add times the 8 and 4 together. Okay? Actually, no equal sign here. Okay. And then 8 times 4 is 32. And just like the indices, we can make the x equal to 32. X equal to 32. Like that. Okay? Just like we did in part A, right? Once they look the same, the powers are the same, or once they look the same, these two can match. Try the next one. Next one's the same. Have a try. Have a try. Let's go through the answers. So using the log law, you get log base 10 x over 5 equal to log base 10 2. So therefore, these must match, right? 2 must match with x over 5. X equal to 10. Beautiful. Okay, one more page, then we're done. We've got some harder question on the next page. So log equation is very easy. Just turn it into index form. Write that in index form. 3 to the power 6. Index form. And then you just make x a subject. 4x is 3 to the power 6 plus 5. And then x equal to, divide that by 4. Alright, so let's do that. Let's have a try. Yep, let's do that. 3 to the power 6. And then plus 5. Then divide by 4. We're going to divide 183.5. Yep, you're right. 183.5. Okay, done. Yeah, same thing for the next one. Have a try. Combine the two logs. Combine them first. Combine. Yep. Combine. Alright, so if you combine, what do we get? So we get log base 3, x minus 1, x plus 1. And there's a fast way of expanding. You get difference of 2 squares, right? And once they match, you can make them equal. Let's make them equal. So x squared minus 1 equal to 8, which is x squared equal to 9. X equal to plus or minus root 9, which is plus or minus 3. But be very careful. In these sort of questions, in this one way, you get a quadratic. See, that's a quadratic. So whenever you get quadratic inside log, you have to check answers because some answers may not work. You need to check. Okay, so we have to check. So let's check the first one. So let's write down the equation again. The equation was log 3x minus 1 plus log base 3x plus 1 equal to log base 3, 8. Now let's check the first one. So check x equal to negative 3. Now if we have negative 3, what happens if you substitute? What does the left hand side become? Log base 3, negative 4, log base 3, negative 2, isn't it? Do we have a log of a negative? No, so that's undefined. So therefore we say that's not a solution. Not a solution. And you can check the other one. X is positive 3. X is positive 3. That should work. X is positive 3. So you get left hand side is this. Log base 3, 2 plus log base 3, 4. No problem. Okay. So you have to write x equal to positive 3 only. So make sure you check your answers with log. So you only have to check the answers when it's a quadratic, like that. You check the answers. But if you don't get quadratic, you don't need to, because you should work. All right, one more question, G. All right, let's do this one. Okay, so for this one, what you do is, you're going to let u equal to log base ex. Okay, so that means you get u minus 1 on 6 on u equal to 5. We'll have to get rid of the denominator. Times by u, times by u, times by u. And you're going to get u squared minus 6 equal to 5u. And what sort of equation do you get? A quadratic. How do you solve this quadratic? We have to factorize. What numbers work? Yep. And once you get that, we can find what u is. U equal to 6 or u equal to negative 1. But don't forget, we're trying to find x. What's u equal to? Log base e x, right? So you have to find what x is. And to do so, you have to write it in index form. What's that in index form? X equal to e to the power of 6 or x equal to e to the power negative 1. So that's your final answer. Now this one you don't need to check. You do not need to check, even though it's a quadratic. No need to check. You only have to check when there's a quadratic inside the log. When it's inside, you have to check. When it's outside, you don't need to check. Okay? Alright, so we're done. So today you got to do exercise 4.5 and we'll do one more tomorrow. Then we'll do more revision next week. Okay? Alright, we're finished.